Okay, for the measurement lab, we're gonna do this pretty much the way that we would have done it in class, except you're gonna be my lab partner, and I'm gonna do the measuring, and you're gonna look at the measurements to fill in the answer sheet table. So if you've looked at the documents, you've got an answer sheet with some stuff at the front for prefixes and how different units are related. I'm gonna walk you through the prefix thing here, do a different video for how different units are related, I think, although I may pin it on this one. And then walk you through the doing the actual measurements and what you do for the table. So, you have to sit through my spiel just like it would be a regular lab. Most people, at some point in their lives, would like to travel. Most people, in some time in their lives, would like to travel somewhere outside of the United States that's not Liberia in Africa or Myanmar in Southeast Asia. Those are the only other two countries in the world that are still officially on the old English measurement system that we still use, even though we're kinda sorta on it, kinda sorta not on it. The rest of the world uses the System International, used to be called the metric system. It's a base 10 system. It uses a bunch of prefixes that always mean the same thing. And then you just put the prefixes in front of the unit. And it means, you know, like centi means you got 100 of the units. Kilo means you got 1,000 of the units. Milli means you've got 1,000th with a TH. 1/1000th of a unit. And whether you're talking about meters or whether you're talking about meters or liters, it always means that. Now, there are some exceptions. It's gotten a little crazy in computers where computer people swiped the prefixes for a while, but because computers were since they work in binary, a lot of the stuff is done in base 16. So for a while, giga and mega and stuff in computers meant something different in the United States than it did elsewhere. They've kind of shifted that where everybody's gone back onto the base 10 system. So, but it's a little confusing. If you try to look something up on the one question that's about computers, you may get a weird number. Just go with what the prefixes mean. Now, you've got some sheets that print out for this, or you can work off of the screen. You gotta print out or work on the answer sheet. You can do that on the screen too, but whether you need paper in front of you is kind of up to you. I will say there are other exceptions. Time. The SI unit dates back to the French Revolution. So about the same time that, or shortly after our American Revolution, the French overthrew the monarchy. And one of the things they did was they established a base 10 measurement system, which included time. I think it was 2 cycles of 10 hours, 100 minutes in an hour, 100 seconds in a minute. They used it for like 20-some years, but nobody else adopted that part of the SI system, so it kind of, they went back to the 60 and 24. Temperature's a little weird. It is kind of a metric thing because it goes 0 freezing point of water to 100 boiling point of water, but it's not really metric, and they don't generally apply the prefixes to temperature measurements. And also, converting from our system to their system is tricky because we don't start with the same 0. Our zeros are at different places, so that gets a little bit tricky. You'll run into that later in the lab. But for the prefix questions, what you get are how many of these are in so many of those. Now, the very first thing I gotta tell you, whole lab, don't give me naked numbers. These numbers all are measurements, so they're numbers and units, and you gotta get the units right. When it says how many meters, it's gonna be an answer, so many meters. When it says how many micrometers, it's gonna be an answer, how many micrometers. You can write it out, you can abbreviate, whatever you wanna do, but I will warn you that for the first 10 questions, 9 of the questions are asking how many of these little things are in these much bigger things, which means you should be getting not just whole numbers, but big whole numbers. Now, sometimes people look at the first page of the information and they get the calculators out and they put the numbers in. They don't get big whole numbers, they get tiny fractional numbers, 0.00 stuff. If you're getting that, you're doing it wrong. Actually, the easiest way to do this is to not use a calculator, it's to break it down into bits and pieces. Like the first question is, how many meters in 15 kilometers? Well, my question from that is, well, how many meters in 1 kilometer? Kilo means 1,000, so 1 kilometer has 1,000 meters, and then how many is 15? If you break it down into those bits, you don't need a calculator to do these. You can just do that step by step by step. It does get tricky when you've got prefixes on both sides. How many milligrams in 6 kilograms? Well, if the first thing you do is figure out what this number actually is, kilo means 1,000, so it's 6,000 grams, then you can do the same thing. How many milligrams in a gram, and then apply that to 6,000 grams. It's not that tricky to do. If you did any kind of math class where you got good at using exponents of 10, those actually work in pretty easily. Some people that are good at that, this is a breeze. But that's your first 10 questions, should all be, except for one. One of them is asking how many of these big things in this really little thing. So it will be a fraction, and it'll be a tiny fraction. But 9 out of the 10 questions should be big whole numbers. And fairly simple, just apply the prefixes from the first page on the introduction and go from that. Now, on the second page of the introduction, we hit something that's kind of neat for the metric system, which is at some point they decided that as they built units, they were going to define units using other units and some sort of very common material, water. So you've got a little list of 3 different ways that they've applied this. And then you've got 3 questions here, so I am going to put it in this part. 3 questions here that use that part of the lab. If you're answering these questions and you're not looking at the part of the lab that has the same heading, you're going to get wildly wrong answers. But it turns out that a liter of water weighs a kilogram. They just decided that that would be the 2 measurements. Kilogram, 1,000 grams, liter of water would weigh a kilogram. So if you have a 2-liter bottle, it weighs a little bit over 4 pounds. Talk about that later. And then it turns out that the definition for calorie is an SI calorie, how much heat, it's a measurement of heat, how much heat does it take to get a gram of water 1 degree warmer on the metric temperature scale, on the Celsius scale. And here you're being asked, how many calories does it take to raise a liter of water? So you got to figure out the mass there in order to do it. Now I do need to warn you, we did it again. People started to dry food up and then burn it and measure the amount of heat that came out versus the amount of heat it took to get it burning. And so that gives you a measurement in calories. And they decided that they would then try to figure in how much of the food you could actually use and how much of it you couldn't. But they came up with the measurement for the energy in food using calories. We like that idea as Americans. But the measurement, 1 gram of water, 1 degree cooler, turns out to be a little piece of heat. We didn't like that, not enough. It gave numbers that were too big for our happiness. So we stole the concept, we stole the word, but we put a capital C on it. And if you see a capital C calorie, it isn't this, it's actually a kilocalorie in the SI unit. It's 1,000 calories. Now, the reason I like to tell people that is you'll see stuff on the internet like, look how many calories you burn doing this thing that doesn't seem like it should be burning any energy at all. It isn't really burning any energy at all. Somebody has not realized that there are 2 different types of calories. They saw a calculation in little c calories, thought it was a calculation in big C calories, and they're off by a factor of 1,000. So anytime somebody tells you how many calories you're burning, like sitting on your butt, chances are they looked at the wrong source. The third question, now, there's two different ways to measure volume. You can measure space and you can measure how much liquid you can put in the space. We use, quarts and ounces and we have two different types of ounces. Our system is crazy. Quarts and ounces and gallons. And then for space, we use like cubic feet and cubic yards and stuff. And we don't have any crossover. I mean, I'm sure there's a number that tells you how many gallons of water there are in a cubic foot of water, but the thing is, in the metric system, a cubic centimeter, a little box of centimeter on each side, holds exactly a milliliter of water. So that water volume and that space volume go together. You can use that to calculate stuff. Here, you got fancy, you installed this big old bathtub in your new house, and you go, well, how much does the bathtub weigh? Okay, we gotta make sure we got supports. We don't want it in the basement. Let's put, we gotta figure in, how much is it gonna weigh if we fill it with water? Really good calculation, right? Well, the bathtub is 2 meters long and 1 meter wide and 1 meter deep. And from that, you need to figure out how much weight you get when you fill it right to the brim with water. One thing to keep in mind. I'm walking you across the lab. Sorry, I frightened you with my face.